students, welcome to Epitome Mining. So we are doing this UPSC PYQ analysis and we are doing the topic-wise PYQ analysis. So today's topic would be the continuation of physical geography from the geography. So the first question would be, in the structure of planet Earth, below the mantle, the core is mainly made up of which one of the following? Option A, aluminium, option B, chromium, option C, iron, and option D, silicon. So if you see the interior of the Earth, it is majorly made up of three major layers. The first layer, the top layer would be the crust, and we have mantle below that, and to the interior we have core. So the crust, if you see, is mainly made up of silicon and aluminium. That's why we call this particular layer as the CL layer. And the mantle is mainly made up of silicon and magnesium. So that's why this particular layer, mantle, is also known as Hema layer. And the core, it is majorly made up of nickel and iron. That's why this particular layer is also known as the knife layer. So what they are asking here is the core. It is mainly made up of which of the following? So one of the option is iron. So the core is actually made up of majorly it is consisting of iron and nickel. And one of the option is iron. So iron is the correct answer. And if you see here, yes, this is the picture of the interior of Earth. The top layer, we call it as the crust. And the next layer, which is inside the Earth, is mantle. So if you see here, the upper mantle and the crust together is known as lithosphere, and the other layer is core. And we already saw the crust is also known as Cl, that is silicon and aluminium, and the mantle is also known as Hema, that is silicon and magnesium, and the core is also known as the knife layer, that is nickel and iron. So let us see in detail what are the characteristics of the crust. So crust is the outermost layer of the Earth. And if you see, this layer is a solid layer. And the thickness of the crust varies under the oceanic and the continental crust. So if you see, usually the continental crusts are much thicker compared to the oceanic crust. The oceanic crusts are very thinner. So the oceanic crust is thinner as compared to the continental crust. And the continental crust is thicker in the areas of major mountain systems. So if you see, let's take the area of Himalayas. So in these areas where there are big mountains or plateaus, we can see the crust is somewhat thicker compared to the other area. Let's say a plain. Take a plain area and take a mountain area. So this mountain area, the crust is thicker compared to the crust of the plains. And if you compare the land area and the oceanic crust, the oceanic crust would be much more thinner than the continental crust. Okay, so the crust is made up of heavier rocks having density of 3 gram per centimeter cube. So this is the density of the crust. The density is 3 gram per centimeter cube, and it consists of some of heavy rocks. And if you see, the kind of rock seen in the oceanic crust is made up of basalt. This is one of the important points. The oceanic crust majorly it is made up of the basalt type of rocks. And this thing we already saw, the silicon and the aluminium are the major constituent minerals which can be seen in the crust. That's why this particular layer, the crust, is also known as Cl layer. Okay, so let us see the next part, that is the mantle. After the crust, we have mantle. So this is also a solid state. Just like the crust, the mantle is also a solid layer, and its density is higher than the crust. We saw the density of crust was 3 gram per centimeter cube, but here the mantle, its density is much higher than the crust. And if you see, the thickness of the crust, thickness of the mantle varies from 10 kilometer to 200 kilometer. Okay. Then the mantle extends from the Mohos discontinuity to the depth of 2,900 kilometers. So if you see, let's say this is the crust and we have the mantle. Let's say this is mantle and we have the core inside that. So this particular layer, that is the adjoining of crust and the mantle, this discontinuity is called as Mohos discontinuity. So the mantle starts from the Mohos discontinuity and it will be along the 2,900 kilometers till that. And then the core will be starting. We will be having the outer core and we will be having the inner core. Okay. So now the next important point is the asthenosphere. The asthenosphere is nothing but the upper portion of the mantle, that is asthenosphere. So let us say here this upper portion of the mantle, we have the asthenosphere. It is also known as the weaker zone. Why? Because the molten magma which is inside the earth, it is usually seen in this particular layer, asthenosphere. And during the volcanic eruption, the magma comes out of the volcano, right? So it comes from the magma chambers which are located in the asthenosphere, and the asthenosphere is part of the upper mantle. Okay, then it is the chief source of magma. Yes, the chief source of magma for the volcanic eruption is the asthenosphere, and that it finds the way to the surface during the volcanic eruption. The crust and the uppermost part of the mantle are called lithosphere. Just now we saw in that picture. The uppermost part of the mantle together with the crust is known as lithosphere. The uppermost part and the crust, these both together is known as lithosphere. Right? Then the major constituent elements of the mantle is silicon and magnesium. That's why this particular layer is also known as Sima layer, S-I-M-A, Sima layer, silicon and magnesium, because these are the major constituents of this particular layer. And the next layer would be the core. And as I already told you, there are two layers in the core itself, the outer core, the inner core. So if you see, let's say this is the outer core and this is the inner core. So the inner core is a solid, but the outer core is a liquid part. So technically this inner core, which is a solid ball, it is revolving inside the liquid core. Okay. So yes, here the inner core is the solid state, whereas the outer core is a liquid state, which you have to remember. Then the core is made up of very heavy material, mostly constituted by the nickel and iron. So that's why this particular layer, the core, is also known as the knife layer, because the major constituents of the core is nickel and iron. And apart from nickel and iron, other major heavy materials or heavy metals can be seen in the core. So the next question, which of the following pairs is or are correctly matched? This side they have given some of the theories which are related to the geography, physical geography, and the associated scientist names are given on this side. So we have to check whether these are the correct pairs. So the first pair is continental drift. They have given that it is related to Edwin Hubble. Second pair is expansion of universe, Alfred Wegener. Third pair is photoelectric effect, Albert Einstein. So if you see here, the first chapter we talk about the universe and the related theories. So the related theories we talk about, so the continental drift theory is not related to Edwin Hubble. Then it is related to whom? It is actually related to the Alfred Wegener. We have read this thing in the static portion. And The expansion of universe theory, this was actually related to the Edwin Hubble. So again, this particular pair is also wrong. And the photoelectric effect, yes, this is actually related to Albert Einstein. So this particular pair is correct. So what is the correct answer? The correct answer is B, 3 only. So the next question, in order of their distance from the sun, which of the following planets lie between Mars and Uranus? Option A, Earth and Jupiter. Option B, Jupiter and Saturn. Option D, Saturn and Earth. Option D, Saturn and Neptune. They are simply asking that which planets actually lie between Mars and Uranus. So let us have a look at the position of the planets. So after the sun, the first planet would be the Mercury, then the Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. So they are simply asking between the Mars and the Uranus, what are the planets which are lying in between these two planets. So these Jupiter and the Saturn, these two planets are lying between Mars and Uranus. So let us go back to this question. What is the correct answer? The correct answer would be Jupiter and Saturn. These two lie between Mars and Uranus. So the next question, what is the approximate mean velocity with which the Earth moves around the Sun in its orbit? Option A, 20 km per second. Option D, 30 km per second. Option C, 40 km per second. Option D, 50 km per second. So if you see here in the question, they are asking that the speed in which the Earth is revolving around the Sun. They are asking what is the mean velocity, what is the speed in which the Earth is revolving around the Sun. So if you see, this is actually a very factual question and the answer would be 29.8 kilometer per second. In this particular speed, the Earth is revolving around the Sun in its own orbit. So what is the approximate value they are asking? So what would be the approximate value? The approximate value would be 30 kilometer per second. Option B is the right answer. So this particular thing we also call it as orbital velocity. The speed at which the Earth is revolving around the Sun. This is also known as orbital velocity of the Earth is the speed with which the Earth moves around the Sun. And what is that? It is 29.8 kilometer per second. At least you have to remember that it is 30 kilometer per second. Then these are some of the important, like other important facts which are directly related to our Earth. So what are they? First one is the mean distance between the Sun. So you can see here the mean distance means the distance between the Sun and the Earth. Okay. Then the equatorial radius. We have the polar radius. And if you clearly see here, the equatorial radius is somewhat higher compared to the polar radius. Can you see that? This is 6,378. But the polar radius is 6,356. So why is that? Why is the difference? So if you see here, let us say this is Earth. So we have the equatorial radius. Radius means from the center point, and we can have this is equatorial radius and this is polar radius. Okay. So what they are saying is this equatorial radius is somewhat higher than the polar radius. Why? Because the Earth is doing the rotation as well as the revolution, right? So what will happen because of this rotation is there is a formation of bulge around the equator. So that's why there is this radius of equator is somewhat higher compared to the poles. And if you see, the poles are comparatively flat and the equator has a bulge. So that's why the equatorial radius is somewhat higher and the polar radius is lesser. You have to remember this also. Then this is the mass of the Earth and the inclination of the equator to the orbit We all know that the earth is inclined, right? And this is the geographical inclination. And what is the value of this geographical inclination? Exactly, it is 23.44 degrees. But we can also say 23.5 degrees or 23 and a half a degree, just for remembering. It is the approximate value, that is 23.5 or 23 and a half. But the exact value is 23.44 degrees. Even though you are not able to remember the exact value, at least try to remember the average or approximate value. Okay. So the next question, they have given the assertion. The same phase of the moon is always presented to the earth. Reason, the moon rotates about its own axis in 23 days, which about the same time that takes to orbit the earth. So they have given assertion, they have given the reason. So if you see the assertion, they are saying that only the same phase of moon is always visible to earth. Is that true? Yes, it is true, because from the earth we can see only one side of the moon. We can't see the other side of the moon. This is correct. So this particular assertion would be a correct statement. And if you see the reason which is given, that is the moon rotates about its own axis in 23 days. Is that so? No. The moon takes about 27 days, approximately about 27 days to rotate, and about the same time is taken to orbit the earth. It takes 27 days to rotate, and it also takes the same 27 days to revolve around the earth. So both revolving around the earth and a complete rotation of the moon is about the same, that is 27 days. That's why we are not able to see the other side of the moon. This is the reason. So what would be the correct answer? The correct answer is, the assertion is right, but the reason given here is a wrong statement. So option C, A is true but R is false. This would be the correct answer. So the next question, again it is an assertion and a reason question. Existence of a human life on Venus is highly improbable. The reason given is, Venus has an extremely high level of carbon dioxide in its atmosphere. So if you see the assertion what they have given, that is, existence of any human life is not possible in the Venus. Is that true? Yes, it is true. In Venus, human life is nearly impossible. Okay, so the assertion is a correct statement. But if you see the reason what they have given here is, Venus has extremely high level of carbon dioxide in its atmosphere. Is that true? Yes, Venus has like extremely high level of carbon dioxide, and that is the reason why existence of human life in Venus is nearly impossible. So if you see here, both the assertion and the reason are correct, and the reason given here is the correct reason for the assertion. So what would be the correct answer? Both A and R are individually true, and R is the correct explanation of A. So option A is the correct answer. So the next question is, consider the following statements. Statement 1, the axis of the Earth's magnetic field is inclined at 23.5 degrees to the geographic axis of the Earth. Statement 2, the Earth's magnetic pole in the northern hemisphere is located on a peninsula in northern Canada. Statement 3, Earth's magnetic equator passes through Tumna in South India. So if you see here, the first statement, it is talking about the Earth's geographical axis and the Earth's magnetic field. It is talking about two things, and it is saying the difference between the Earth's magnetic pole and the Earth's geographic axis. So if you see, usually we know that the Earth is inclined for about 23.5, just now we saw degree. This is nothing but the geographical inclination. They are not talking about the geographical inclination, that is 23.5. No, they are saying that the difference between the Earth's geographical axis and the Earth's magnetic field. So if you see here the Earth's magnetic field, it will be somewhat similar to this line. I shall draw this line in a different color so that you will be able to understand. So if you see here, this particular red line, you can see the red color line here. So this is the geographical axis. This geographical axis is inclined for about 23.5 or 23.5 degree. This thing we know. But if you see the green color line here, this is the Earth's magnetic pole or the magnetic field. Okay, so what they are saying is the axis of Earth's magnetic field is inclined at dash to the geographic axis of the Earth. So if you see, the difference would be somewhere around 11.5 degree between the Earth's geographical axis and the Earth's magnetic field. So this particular thing which they have given 23.5 degree is wrong. The correct difference would be 11.5 degree. So this particular statement is a wrong statement. Okay. Statement 2. The Earth's magnetic pole in the northern hemisphere is located on the peninsula in the northern Canada. So they are talking about the magnetic pole. So what is the magnetic pole here? That is a green color line. So this particular green color line, they are saying that it passes through the peninsula in the North Canada. So this is correct. Yes, it passes through the peninsula in the North Canada. And the third statement, Earth's magnetic equator. Earth's magnetic equator passes through Tumna in South India. So again, the magnetic equator, it passes through Tumna in the southern hemisphere, South India. So these two statements are correct. Statement 1 is wrong. So correct answer would be B, option 2 and 3. So if you see here, you can clearly understand what is this magnetic pole. So if you see this dotted line, that is the magnetic pole. And if you see the other line, that is the geographic pole. For your understanding, let me make it in different color. So if you see here, this red color line which you can see, right, this red color line is nothing but the geographic pole. So we have geographic North Pole and South Pole, and the green color line which you can see, it would be connected like this. The green line and the red line would be connected like this. So the green color line is the magnetic pole. And if you clearly see the Earth, let's say this is Earth's North Pole. Okay, let's say this is the northern hemisphere and it is the North Pole. As we know, the Earth's North Pole. But this side, the magnetic pole, this would be the South magnetic pole. And just in case of the other pole, it would be opposite again. So let's say this is Earth's South Pole, then the magnetic pole would be a North Pole, right? So in the question, they were simply asking what would be the difference of angle between the Earth's geographic pole and the Earth's magnetic pole. So it would be approximately about 11.5 degree. So that would be the correct answer. So let us go to the next question. Consider the following statements. Statement 1. Total area, land area of Earth is approximately 1475 lakh square kilometers. Statement 2. The ratio of land area to water area of Earth is approximately 1:4. Statement 3. The maximum percentage of Earth's water is in Pacific Ocean. So if you see here, the first statement, it is a factual statement, yes, the total land area would be approximately 1475 lakh kilometers square. That statement is correct. And if you see the second statement, ratio of land area to the water area. We know this thing, right? At least we know the percentage. Nearly 71% of Earth's surface is covered with water, and nearly 29% of Earth's surface is the land area. And if you see the ratio, it will definitely not be 1:4. This thing we know. So we can eliminate this option. Then third statement is maximum percentage of Earth's water is in Pacific Ocean. Is that true? Yes. Out of this 71% of water surface area, it is covered maximum in the Pacific Ocean. So this statement is correct statement. So the correct answer would be answer 1 and C. Option A is the correct answer. So the next question, which one of the following is the correct sequence of the given continents in decreasing order of their percentage of Earth's land? Option A, North America, Africa, South America, Europe. And option B, C, D, they have just shuffled them. They have given the same option, just shuffled them. Okay. So if you see here, they are asking about the continents. We have 7 continents. They have given 4 continents here, and they are asking the decreasing order, the largest continent to the smallest continent. So let us have the look at the continents here. So we all know what is the largest continent, that is Asia. So that is first place. Then Africa is the second largest continent. The third would be North America. Fourth would be South America. Then we have Antarctica. Antarctica is fifth largest. Then we have Europe. Then we have Australia. So this is the order of the continents from the largest to the smallest. Here they have given that, they have given North America, Africa, South America, Europe. So if you see what would be the largest continent given here, that is Africa. So Africa, here there is another Africa. So we can eliminate the other 2 options. Then we have North America, yes, the second is North America. Then third is South America. Here they have given Europe. So we can eliminate this option as well. So the correct answer would be option B, Africa, North America, South America, then Europe. Yes, this is the correct answer. So the next question, consider the following geological phenomena. 1. Development of a fault. 2. Movement along a fault. 3. Impact produced by volcanic eruptions. 4. Folding of rocks. So what they are asking is, which of the above cause earthquakes? So if you see here, they are talking about the development of a fault and movement along the fault. What is this fault? We know the top layer of Earth is crust, and below the crust we have some rocks, right? Some plates. This is made up of plates, and sometimes there would be some sort of fracture in this particular plate or the crust. There would be some sort of fracture. This fracture, this will cause a gap between 2 plates. Let's say these are the 2 plates, and there is a fracture between these 2 plates. So these fractures, as we know, there are some areas where the crust is very thinner, and due to other activities, there is internal movement of magma. The plate itself is moving. So there are many activities which are happening inside the Earth. So because of this, where the crust is very thinner, it is prone to breakage and formation of fault. So if there is a formation of fault, that is, there is a development of a fault in a particular crust, let's say interior of Earth. So what will happen? When there is a sudden release of energy from a rock, that is known as earthquake. The sudden release of high amount of energy. So it will lead to the cause of earthquake. So yes, development of fault is there. Then movement along fault. Let's say there is already a fault and there is a plate here and there is another plate here. There are two plates here and there is a fault. Okay. Now there is a movement. What type of movements are there? One is we have this continent-continent divergence and continent-continent convergence. Then we have transverse boundary. So these type of movements are already happening in the plates, right? So let's say there is two plates moving against each other, or let's say the plates are moving away from each other. Okay, or they are moving in the transverse direction. In all the cases when there is a movement along the fault, what will happen? Again, the sudden release of high amount of energy will happen and it will cause earthquake. So movement along the fault, it will also cause earthquake. Next we have impact produced by volcanic eruption. So do volcanic eruption cause earthquake? So the answer is, let's say this is the volcano, structure of volcano, and we few questions back we read that the magma chamber, it is present in the asthenosphere. Let's say this layer is the asthenosphere and there is the magma chamber. A lot of magma is flowing here, okay, like this. Now let us say this magma is coming out and it is erupting, okay, in the form of volcano. Now what happens? Let's say in this place there was already magma flowing. This magma load are taken out. They came out. Okay. So what will happen here? There will be empty space here. Okay. The magma load is already gone out. So now because of the pressure, there are heavy rocks here. Okay. So because of this pressure towards downwards, so what will happen? They collapse and they fall in this empty space. And this will also cause the sudden release of energy and it will also cause the earthquake. So yes, impact of a volcanic eruption, it can also cause earthquake. Then we have folding of rocks. So what is this folding of rocks? We usually read in the static portion. What is that? Whenever we have a continent-continent convergence, both plates are coming together. What will happen? There will be folding of rocks will happen. Let's say there is a continent, or there is a plate here, there is another plate here, and they are moving towards each other. So what will happen once they collide with each other? There will be folding of rock or fold mountains will be forming along this boundary. And we also read this that along the boundaries, especially the convergent boundaries, that where the plates are convergent, there it is prone to earthquakes. So we have this Himalayas, yes, they are fold mountains because we have convergence of the Indian subcontinent plate and the Eurasian plate. So what happens there? That particular Himalayas, through those folding, it is prone to earthquake, right? So yes, folding of rocks, this will also cause earthquake. So what would be the correct answer? The correct answer is B, 1, 2, 3 and 4. So the next question, identify the correct order of processes of soil erosion from the following. Option A, splash erosion, sheet erosion, rill erosion, gully erosion. So again, in the other options, they have just switched the places of the order. So if you see these erosions, we are talking about the soil erosion. And if you clearly remember, we have read this in the static portion. What is this splash erosion? Splash erosion is whenever the rain is coming. Okay, when the rain drops, it falls on the soil. A splash is happening, and this particular splash will erode the soil. The top layer of the soil will be coming out because of this splash. So this is splash erosion. And what is sheet erosion? After some time, After some raindrops they collect together, and a small stream will be flowing just like a river. If you see, a small stream will be flowing in a direction, okay, from upward direction to a downward direction. It will be similar to a river, but it is somewhat very small, okay, small stream. So if you see here in this particular sheet erosion, what will happen is the top layer of the soil, whichever due to the splash erosion, it was taken away. Now this sheet erosion is going to carry all these top layers in the stream itself. So if you see the picture here, yes, see here, it is carrying those top layer of the soil along with the stream, and it will deposit in the wave. So this is sheet erosion. And the next procedure would be, so first splash erosion will be happening, then the sheet erosion will be happening, next the rill erosion will be happening. So again, after some time, the sheet erosion, if it continues, this particular area, this particular soil, it will keep on widening, right? So then it will form something like this. A widening of that particular soil will be happening, and this particular erosion is called a rill erosion. And then after some more time, when some more water is flowing again and again, after some more days or some more time, what will happen? This particular thing will widen again. It will widen to this extent that it will nearly become so big. A person can stand here. It's that much bigger. Okay. So this erosion is called as a gully erosion. Okay. So what is the order? First, the splash erosion will be happening. Then it will convert into the sheet erosion. Then a rill erosion. Then a gully erosion. So this is the order of the soil erosion which is there. So let us go back to this question. So if you see option A, splash erosion, yes. First thing is splash erosion. Then it will convert into a sheet erosion. Then rill erosion. Then a gully erosion. So option A is the correct answer. It is in the correct order. So that's all for today's class. Thank you, students. Let us see in the next class. We'll be continuing with this particular topic. And in the next video, we'll be completing the whole topic, physical geography. So thank you, students.